China's tiltrotor aircraft development has reached a significant milestone, marking a new chapter in its broader aerospace strategy. This new phase represents not just a technical achievement but a calculated step toward transforming the way it approaches vertical lift, long-range logistics, and flexible aerial mobility across diverse terrain and environments. The emergence of both a manned and a heavy uncrewed tiltrotor platform indicates a deliberate and long-term commitment to a technology that blends the vertical takeoff advantages of helicopters with the speed and range of fixed-wing aircraft. The manned tiltrotor platform, developed by Harbin Aircraft Industry Group under AVIC, has completed its maiden flight in 2025. This aircraft is a mid-sized, twin-engine tiltrotor with a conventional straight-wing, twin-rotor layout, and AT-tail configuration. It features engines fixed to the nacelles while the rotors themselves are designed to tilt. This design choice is critical. By fixing the engines and only tilting the rotors, engineers can simplify the drive train and reduce mechanical stress, while maintaining the unique advantages of a tiltrotor system: vertical takeoff and landing (VTOL), high cruise speed, and extended range. This particular tiltrotor configuration includes a cross-shafted transmission, which allows power from one engine to be distributed to both rotors in the event of an engine failure. This safety feature is essential in any operational environment where survivability and reliability are priorities. The aircraft is equipped with retractable landing gear and a pressurized cabin, suggesting an intended operational ceiling higher than that of typical rotary wing aircraft. The interior configuration, though not disclosed in detail, likely supports flexible use, cargo transport, personnel movement, and potentially equipment for surveillance or communication tasks. This development marks a significant step forward. Until now, China's tiltrotor work had remained largely theoretical or conceptual, with only wind tunnel models, CGI renderings, or lab-scale propulsion systems on public display. The successful flight of a full-scale, manned aircraft indicates that China's aerospace industry has mastered not only the aerodynamic and mechanical challenges of tiltrotor design but also the systems integration necessary to make the platform viable. Such a leap is not trivial. It requires coordination across airframe manufacturing, propulsion development, flight control software, and structural analysis. The ability to produce a flying prototype suggests a high degree of technological self-sufficiency. Alongside the manned platform is the heavy uncrewed tiltrotor aircraft, developed by United Aircraft Group. This system, known by its development code UR6000 or R6000, is a 6-ton class UAV powered by the AES-100 turboshaft engine. With hover tests already completed and transition flight testing underway, it represents one of the heaviest uncrewed tiltrotor systems in development globally. Its intended performance envelope is ambitious: a cruise speed of over 500 km per hour and a range of up to 4,000 km. These figures exceed what most conventional rotary wing UAVs can offer, opening possibilities for long-distance resupply missions, maritime logistics, and autonomous airlift in rugged or undeveloped regions. The R6000's payload capacity, approximately 2 tons, enables it to carry significant cargo or mission systems. Its utility spans multiple sectors: transport of high-priority materials, disaster relief in inaccessible zones, and rapid resupply across dispersed or isolated outposts. Given its scale and propulsion, it is capable of operating with a high degree of independence, and likely features autonomous or semi-autonomous control systems tailored for long-endurance missions. Importantly, this aircraft allows China to develop new logistics models that are less dependent on fixed infrastructure like airports or ground transportation corridors. The parallel development of these two aircraft, one manned, one uncrewed, is not coincidental. It reflects a systems-level approach, where both platforms may be intended to operate in coordination or to fill complementary roles. For instance, the crewed version could be used for missions requiring direct human involvement, oversight, or rapid deployment of personnel, while the uncrewed system can perform repetitive or high-risk missions that don't require a pilot on board. This dual-track strategy increases operational resilience and flexibility, especially in scenarios where communications may be disrupted or terrain makes traditional approaches infeasible. These developments do not exist in isolation. They are part of a broader transformation within China's aerospace sector. Over the past 2 decades, there has been a systematic effort to move from a position of dependency and imitation to one of innovation and self-reliance. By investing in complex air systems like tiltrotors, which demand high-level proficiency in aerodynamics, flight dynamics, and advanced materials, China is signaling that it no longer intends to rely on legacy aviation models or foreign designs. Instead, it is moving into frontier domains, where few countries have succeeded in operationalizing advanced platforms. Mastering tiltrotor technology is particularly symbolic. It has long been regarded as a benchmark of high-end aerospace capability, due to its technical complexity and dual-mode flight requirements. Historically, very few countries have developed and fielded such aircraft due to cost, development risk, and operational integration challenges. By fielding both crewed and uncrewed tiltrotors, China is asserting its ability to overcome these obstacles through indigenous effort, coordinated research, and a vertically integrated aerospace industry. These platforms also support a broader shift toward rapid mobility and decentralized operations. Whether in support of humanitarian efforts, infrastructure delivery, or support for distant operations in remote terrain, tiltrotor systems offer flexibility that traditional aircraft cannot. They are capable of reaching isolated locations without needing runways, and they can deploy faster than conventional helicopters while carrying heavier loads or reaching further distances. In this context, tiltrotors provide not just tactical but strategic utility. Moreover, China's emphasis on both automation and long-range VTOL reflects a desire to redefine how aerial logistics are conducted. The uncrewed platform, in particular, may lay the groundwork for fully autonomous cargo delivery networks. These systems can be deployed in areas with limited infrastructure, high operational risk, or unpredictable environmental conditions. The ability to conduct long-range autonomous flights at high speeds reduces time delays, lowers operational risk, and introduces a new level of efficiency to logistics. Taken together, these advancements reflect a deliberate strategy to dominate emerging aerospace domains. They show that China is moving quickly to fill capability gaps with homegrown solutions, relying on its own engine designs, airframe architecture, and control systems. It is not simply catching up to existing technologies, it is repositioning its aerospace development roadmap toward areas that allow for maximum impact with asymmetric advantages. What is important to understand is that these systems are still evolving. While the first flights mark a milestone, the path to full operational deployment involves intensive flight testing, refinement of systems integration, durability trials, and user feedback. The next 2 to 5 years will determine how robust these platforms truly are, how well they perform under demanding conditions, and whether they can be produced at scale. But the direction is unmistakable. China is investing in a class of aircraft that could significantly alter how aerial mobility is defined and implemented. China's tiltrotor developments represent far more than a technical experiment or demonstration. They are a signal of future intent, a recalibration of aerospace strategy, and a reflection of growing confidence in domestic innovation. Through these platforms, China is building the foundations of a next-generation air mobility architecture, one that is fast, flexible, and increasingly autonomous.